Here is an implementation of binary search tree in C language with basic operations like insertion, search, and deletion. Let's go through the binary search tree implementation step by step, explaining the code line by line along with the output. First, we will define the structure. This defines a structure node to represent a single node of binary search tree. Each node contains data and integer values stored in node, pointer to the left child and pointer to the right child. Now let's create a node. This allocates memory for a new node, assigns the given value to data, and initializes both left and right children as null, since the node doesn't have any children when created. Now insert a node into the tree. This inserts a new value into the binary search tree. It means the tree is empty, so we return a newly created node. If value is smaller than the current node's data, we insert it in a left subtree. If the value is greater, we insert it in a right subtree. Finally, the function returns the root node after the insertion. Now let us search for a node in a tree. This recursively searches for a node in the tree. This line indicates the node is not found. If the node's data matches the search value, return the node. If the value is smaller, search in the left subtree. If the value is greater, search in the right subtree. Now find the minimum value node. It is used for deletion. This finds the node with the smallest value in the right subtree, which is used when deleting a node with two children. The smallest node is the leftmost node. Now delete a node from the tree. This removes a node from the tree. First, the node to be deleted is found. In case 1, the node has no children or one child. If the node has one child, we replace the node with its child. In case 2, the node has two children. We find the in-order successor, that is smallest node in the right subtree. Replace the node's value with that successor and delete the successor. In-order traversal. This recursively visits the left subtree, the root, and then right subtree. This results in printing the nodes in the sorted order. Now let's write the main function. Insert the nodes. Nodes with values 50, 30, 70, 20, 40, 60, and 80 are inserted into the binary search tree. The in-order traversal prints the values in ascending order, that is 20, 30, 40, 50, 60, 70, 80. Then we search for a node 40 and search is successful. So node 40 is found in the binary search tree and it is printed. Delete the node. Node 40 is deleted from the tree. After deletion, the in-order traversal prints 20, 30, 50, 60, 70, and 80. The final output would be like this. In-order traversal of the binary search tree is 20, 30, 40, 50, 60, 70, and 80. Node 40 is found in the binary search tree. In-order traversal after deleting 40. 20, 30, 50, 60, 70, and 80. This output reflects the order of insertion, search, and deletion in the binary search tree.